All right, 4.1, formulas and variables. First, we're going to look at filling in data tables. And to do that, basically, we put numbers in for x. Usually x are the independent variable. And that independent variable is usually going to be sandwiched inside an equation with other numbers to find y, which is the dependent variable. So if you think about equations, usually they're in the form of something like y equals 3x or y equals 3x plus 2. So what I'm saying is you could put a number in here for x, like say put in a 4, then you could find y. 3 times 4 is 12, plus 2, 14. Okay, I dedicate this first example to my wife, who dropped physics, which is what I majored in college, and took home ec. And she learned how to cook very well. Okay, the average weight of a married male is 170 plus 2 pounds for every year T he has been married. So the weight depends on how many years he's been married. So the independent, or like the x values, typically go in the first row. The weight is going to depend on how long he's been married. So if we write an equation for that, weight, well, it says the weight is like the equals, 170 pounds plus 2 pounds for every year. So 170 plus 2 pounds for every year he's been married. So after 1 year, it'd be 172. After 2 years, it'd be 174. After 3 years, 176. So you kind of catch the pattern, which is what I did after I got married. But so this here is going to be a T for time. So you could write an equation, the weight then of the person equals 170 plus 2 times the number of years they've been married. All right, and from this we can fill in the data table by just taking these different x values, or independent variable values, or t values, and putting them in here for t. So if I put a 0 in here, order of operations tells me I have to do 2 times 0 first to get 0. 170 plus 0 is 170. So I weighed about that when I was married. 1 year later, I put a 1 in here. 2 times 1 is 2. 170 plus 2, 172. 5 years later, all right, so I have 2 times 5, or 10, plus 170. I'm up to 180. It's getting bigger. So, okay, so then 2 times 10 after 10 years of marriage, so 20, plus 170 is 190, and this is where we start reversing the trend. So, okay, but 25. So if you're married for 25 years, that'd be 50 plus 170, so 220. In 50 years, 2 times 50 is 100, plus 170 is 270. Okay, enough about that. Yeah, alrighty then. So pay, if we were to do something like this, pay, P, is $8 an hour. So pay depends on the number of hours. So I'm going to put P for pay down here because that's the dependent. This is always the dependent variable, or the dependent row. Then the independent is the H. All right. So you could ask yourself, what's the equation going to look like? Well, after 1 hour, I'd make $8. After 2 hours, I'd make $16. After 3 hours, I'd make 24. So to figure out my pay, I'm always doing 8 times the number of hours that I work. All right, we can fill in the data table then. 8 times 2, coming from right there, gives me $16. If I take my 5, put it in for H, I get 40. 8 times 8 hours would be 64. Or 8 times 40, well, 8 times 4 is 32. So 8 times 40 would be 320. All right, almost done with page 1. Then we start doing it the opposite direction. Car salesman. A lot of people earn commission sort of thing. So let's say a car salesman earns $10,000 a year. So we could do an S for salary, but it says earns. Maybe I'll do like a E. The amount he earns is $10,000. So he gets 10 grand for working there, plus, or and, gets $200 commission for every car sold. So maybe I'll put 200. So if he sells 1 car, he gets 10,000 and 200. 2 cars, you get 10,000 plus 400. So it's going to be this 200 times the number of cars that he's using. So cars is the independent, that goes first. the amount of earnings depends on it, so it goes there. And chances are this is beyond what you guys have learned, but really people never use lowercase e or lowercase c for variables. I'm like doing two big no-nos in one thing. You'll understand it more when you take physics later on, or algebra too. But anywho, all right, if he sells 0 cars, he's like, dude, I'm just going to sit in the office. He's going to get 10,000 plus 200 times 0. He's going to make 10 grand a year for doing nothing. All right, if he sells 100 cars, so I'd take and put 100 in there. So that would be 200 times 100 would be 20,000. So he'd get $30,000. So $30,000. Okay, we can keep going. If we put 200, he sells 200 cars. So 200 in there would give me 200 times 200, or 40,000, plus 10,000. Now he's up to $50,000. And then last but not least, if he sells 350 cars, 200 times 350 is 70,000, plus the 10. He'd be making 80,000 a year, or she. And by the way, I totally made up that equation. I don't know what car salesmen get paid. Probably depends on the value of the car they sell. Next we have page 2, and I just redid the notes this year, and I did not see to take this out, so yours shouldn't have that in there by the time you get to it. But let's look at what we have going on. So getting an equation from a data table. In other words, we're trying to figure out what equation could we write that tells us how to get these numbers from those numbers. So we're always going to start and have that bottom variable be our variable that equals, because the y, that's in the dependent camp or category. If you have a data table like this, then the variable here, because x will always be listed first, the independent, followed by the y, the dependent. So that'll be the variable that's by itself. So that variable equals. Okay, now we just need to find a rule. And for me, what I do is zeros often aren't insanely helpful, but when we look at this 1 and 7, I say, well, how could I get a number 1 and change it to a 7? And the first thing I do is think, oh, it went up, so I'm going to say add 6. 1 plus 6 gets me 7. Then to see if that rule works for all the numbers, you just keep going. Does 2 plus 6 equals 14? No, it does not. It equals 8. So that tells us that this plus 6 can't be right. So you're back to the drawing board. What's another way to change a 1 into a 7? Well, I could take and I could multiply by 7. And then, well, here, does that work for this here? Yep. 2 times 7 gives me 14. And 3 times 7 is 21. 5 times 7 is 35. So in other words, we're taking our x values times 7. So some people will do like x times 7 like this, but that's really not proper, and you really shouldn't be writing them that way. It is a x times 7, but when we have a number and a variable multiplied by each other, we always do the number first. So from now on, get into the habit of doing 7x. So for this first one, it's going to be y equals 7x, or 7 times x. Okay, example 5, we have this here. And all right, so I go, what are my ways to turn a 1 into a 5? I usually start with addition just because it's easier, but it could be 1 times 5 or 1 plus 4. All right, let's see. Yep, plus 4 works there, plus 4 works here, and plus 4 works there. Okay, so we take our bottom equation, which is y, we say y equals, and it's always the x value plus 4. So the equation there would be y equals x plus 4. Okay. This next one, looking at how do we take and change a 4 into a negative 8. Well, it could be subtracting 12. So if I start there, let's say I minus 12. Because minusing 4, subtracting 4 get me to 0. Then subtracting another 8 gets me a total subtraction of negative 12. And then here, though, ooh, that'd be a minus 15. So it can't be the subtraction. That doesn't seem to be working. Well, 4 times 2 is 8, but I need the negative. If I multiply by a negative 2, that seems to work. And I'm doing like an x for multiplication. Maybe I should be doing the dot. 5 times negative 2, sure enough, that's negative 10. 6 times a negative 2 is negative 12. 10 times negative 2 is negative 20. Yep, so I'm always finding y I always multiply my x value by negative 2. But going back to that example we had before, if you have a variable and a number multiplied, you always put the number first. So y equals negative 2x. Okay, last but not least, we have another way where the y values are smaller than the x values. So, okay, so I'm going from a 3 to a 1. So I'm going to say, okay, if we subtract 2, yep, then we have a 4 to a 2. Well, subtracting 2 works there. And subtract 2 and subtract 2. Sure enough. The other option would have been, at least for here, like divide by 3, but then this would be divide by 2, divide by something ugly, so it ends up being just subtracting 2 each time. Okay, so to write it, our y value is right there, so we say y equals, and each time we did our x value minus 2. So final comment, you'll notice when you add or subtract, you do the variable first. We had that in examples 5 and 7 there. That subtraction addition, you do the variable plus the number, variable minus the number. There's multiplication, it'll be the number times the variable. That's it for this section. Let me know in class if I can help you. And that's in theory what we learned in the homework.